Hi, this is a brief intro regarding the contents of this channel. But first, let me quickly go over what typesetting tools in general aim to achieve and why it's important to acknowledge types entering this space. If writing is a script of a play, then typesetting presents itself as the stage design, lighting, and costumes that bring it to life. So while MS Word is one of the most used typesetting software, it's only ever used as a WYSIWYG editor, limiting the extent of customization. On the other hand, Figma is customizable, yet you wouldn't want to use it for a 100-page article, because you would have to indent every paragraph, or more importantly, draw every page manually. This is where being able to edit your document's contents in plain text is superior, and merely a couple of names are known for doing this very well. Right now might be an appropriate moment to talk about the pronunciation for both of them. LaTeX is correctly LaTeX or LaTeX, so not polymer, and Typest is correctly Typst, so not a worker. Do not confuse LaTeX with regex. Anyway, LaTeX, a derivative of TeX before it, came into existence around the same time that MS Word's development started in the early 1980s. In recent years, Typest is being introduced as a modern replacement for LaTeX. It's even boldly claimed as such on their official website. But what even are these two used for? They're both open source typesetting software, or rather their own ecosystems. Today, LaTeX is being maintained by the LaTeX project, while Typest is a company based in Berlin, Germany. Before going over the differences, let's name a few similarities. They have growing communities, and as such they both are very versatile. For example, you're not locked to a single editor, as is the case with WYSIWYG and MS Word. Examples of that are community-driven LyX and LaTeX and TyX and Typst. Therefore, many editors are possible to be used both online or offline and come through various different means of installation. The latter also touches on the fact that they are open source, so they found their way onto pretty much every operating system imaginable. Though not installed by default. Since LaTeX and Typst files are stored in a plain text format, it's possible for an average user to edit them with even the most basic text editors. Remember, MS Word is constrained to Windows, as well as using a proprietary file format. You may consider all so far mentioned features as either pros or cons, but I think they're definitely pros. To my knowledge, LaTeX is pretty much feature complete apart from accessibility, such as robust use of screen readers and PDF. This of course isn't the case for Typst, and for this reason, there's this nicely put together Typst roadmap to see what features its developers are prioritizing. Keep in mind that what you see here is an ever-changing web page. Of course, if you don't yet find something available in Typst, you're more than welcome to implement it yourself, at least with enough dedication or money. Where LaTeX and Typst really shine compared to something like MS Word is in their modular approach. By this I mean that you generally start out with what's called a preamble, which ideally separates all styling from the content form. It precedes the main content of your document, because that way it gets executed first during the compilation process, and your style is determined before the contents are laid out. It's the same concept as writing functions above in C, but even more similar to how CSS and HTML work together to present your web page. LaTeX pretty much enforces that you do this, while in Typest it's more of a convention, where you'll struggle if you don't follow it. So anything you specify in the preamble instantly updates across the entirety of your document, and generally without any need for tedious intervention on the affected parts. You probably heard me mention compilation. This is another thing you don't have to deal with in WYSIWYG editors, because everything there updates instantly. But here, with each change you make in your plain text file, you need to recompile it into the final form of the document, meaning all of that human readable code translates into a mess of alienated glyphs called a PDF, or whatever you're exporting into. The same principle applies for compiling a C program beforehand in order to obtain an executable file which then displays a hello world message. As your document gets longer, compilation time increases will be much more noticeable in LaTeX than they will be in Typest. You'll also notice that LaTeX is predominantly made around occasional recompilation, while Typest can consistently, so regardless of document size, afford to recompile at near real-time speeds. If I had to estimate, I would say I've had maximum compiled time somewhere in the neighborhood of 10 seconds than 10 milliseconds in LaTeX and Typst respectively, but it of course also differs from machine to machine. By the way, both LaTeX and Typst are Turing complete, meaning you could, in theory, use them as a regular programming language. Some features never make it into base builds of LaTeX or Typst because they describe very specific nuances or because they can be done in many different but equally representative ways. That's why packages exist. With LaTeX, you can search through them on C10, and with Typst, that's possible on their Typest Universe website. It's quite difficult to typeset maths in LaTeX without a single package like AmsMath, which quickly slows down compilation time. On the other hand, I rarely see myself using packages in Typest. Exactly what can you contribute to LaTeX and Typest? GitHub posts the source code for both, but I think Typest repositories are at least at the moment less fragmented and therefore easier to understand. What if you encounter an error or don't know how to approach a problem? You will find that 90% of your problems with LaTeX have already been answered on LaTeX Stack Exchange. Otherwise, I find our /LaTeX a good place to ask around for answers also. Typest has a growing collection of answered questions available through Discord. It is especially useful for asking quick questions. Following the closure of Typest GitHub discussions, the official Typest forum also opened. As is the case with LaTeX, you can visit somewhat less active r/Typest. Surprisingly, there is no form of wiki available for Typest, but there is comprehensive documentation on their website, slightly resembling Overleaf's documentation pages. Overleaf is a very popular collaborative LaTeX editor, but also known for its collection of guides. Assuming that this is your first time learning about Typest, I would recommend you to gradually understand what Typest can do for you. Whenever you inevitably hit a roadblock, you shouldn't immediately give up Typest, because although LaTeX is already very stable and well established, it could use some friendly competition. It's almost starting to sound like Windows versus Linux. Anyway, if you're familiar with LaTeX, then great. You already know how to go about acquiring this new set of typesetting skills. In my opinion, as it stands in 2025, there certainly are important features that LaTeX has me coming back for. Inserting external plain text content. With Typest, I sometimes get the feeling that the code is too spread out vertically compared to the more densely packed LaTeX code, especially with the preamble part where the majority of styling commands resides. For that reason, it's sometimes helpful to externalize parts of the document which cause too much visual clutter. LaTeX allows you to insert plain text very easily with just \input, and it acts as if it were part of the main document. Inserting PDF. I'm probably the gazillionth person mentioning it. In LaTeX, this is achieved with the package pdfpages. PDF forms. From my experience, they are especially useful for obtaining digitally signed copies. In LaTeX, this is achieved with the package forms. Despite making it easy to display highlighted code blocks, such as the ones you see in Markdown, I feel like there's a great lack of customization past that, even when utilizing the currently available packages from Typest Universe. Native 3D drawing the way Asymptote achieves it. I really like the WebGL export option with Asymptote, and its geometrical drawing capabilities in 3D are also amazing. Admittedly, it's far from easy to conquer. Multi-column layouts and image wrapping are something that is possible, but only to some extent that doesn't really functionally hold up. If your work involves text, graphical elements, and limited amount of maths, then the cell typesetter or desktop publishing software like Scrabus would be a more sensible solution. Stricter consistency measures. While the compilation messages are somewhat better in Typest, it has happened before that I missed a delimiter somewhere, and was surprised no warning showed up about it. The placement of commas is also much more unconstrained, which can lead to inconsistencies throughout the document, especially when more people work on it. Apart from that, I think it's completely reasonable to start up with Typest, and you're more often than not going to find that only external forces, such as journals, will want you to keep using LaTeX. The lack of packages and tools, such as OCR, is not a massive deal breaker unless you're a bleeding edge scientist in need of a special mathematical symbol, which I think you can hack together quite easily most of the time. One thing I can see being a deal breaker, however, is somewhat incomplete internationalization in the context of microtypography, but I'm not very keen on that. Converting the entire world from English to Esperanto would be a near impossible feat nowadays, whereas changing the means of communication through typesetting is becoming increasingly more plausible. Not to disregard any lesser known typesetters, I want to give honourable mentions to Troff, Graph, and Layout, all of which I believe have their own niche use cases. Before ending, I want to now actually discuss what I intend to upload on the channel. I've known about Typest since around 2023, but I've been actively using it since this year, 2025, and have grown used to it relatively easily. I intend to occasionally upload short duration tutorials, with the main focus being on everyday problems which you may encounter in use of Typest, but also comparing or referencing it back to LaTeX. Despite the targeted video length, I'll try to stay away from posting YouTube shorts, because I don't like how YouTube manages them. With age being one of the main differences between LaTeX and Typest, as Typest is like a fast evolving baby compared to LaTeX, I'll attempt to incrementally upload only what I think won't fundamentally change in the language and will remain long term. This means that at any time you'll be able to watch what I deem the most efficient ways of achieving particular results with Typest. If something I post then becomes deprecated regardless, please notify me in the comments so that I can add a disclaimer somewhere. This video was very much an exception to that because I mentioned many time variable features.